Let's get started. Good morning, everyone, and welcome to ATC 323, so hopefully in the right space. And I'm going to go through architecting highly available geo-redundant cloud solutions with Windows Azure. For those who I haven't met, my name is Graham Elliott. I work for Microsoft, and my job is to work with independent software vendors across Asia to help them implement their solutions on Azure. And there's really two things I want to go through today. The first is I'm going to take you through a bunch of architectures and design patterns for how do you do fault-tolerant, highly available solutions with disaster recovery on Azure that are geographically distributed. And what I'm also going to go through is a little bit of the underlying technology that I talk about through the architecture. So I've got some what are fairly basic demos, but hopefully they'll give you a flavour of some of the technology underneath. What I do want to cover first, though, is a tiny bit of context just to set the scene about why we actually care about this stuff and what do we actually need to think about. So I'm just curious in the room, who here is a developer? Cool. Who's an IT pro? Okay, perfect. So hopefully I've got a mix of both content. Being an architecture session, it's kind of at that broader level. And who here's familiar with Azure in some form? Who's done a lot of work with Azure? Okay, who kind of doesn't have a lot of experience with Azure? Okay, perfect. So hopefully I've tried to balance the content towards both of you as well. So there's some stuff those that are familiar with Azure have used and maybe haven't used, and those that aren't familiar with it, hopefully you'll get a good introduction. So let's start by setting a little bit of context. Why do I care about this stuff? Right? If you're going to choose a public cloud platform, surely that comes with the promise of high availability, fault tolerance, disaster recovery, right? And the answer is, well, yes, maybe a little bit, but the real answer is stuff happens, right? Large-scale failures in the cloud aren't very common, but they do happen. What's more common is small-scale failures, failures to subsystems, degradation in service, human error, whether it's on our side or whether it's on your side. Issues that happen with the application, right? Database corruption, whatever it is, stuff happens. And as the owner of the application, it's your responsibility to maintain the user experience of your solution, right? Which means you are ultimately responsible for fault tolerance, disaster recovery, high availability, no matter what the platform gives you itself. And so if we look at these three concepts, which are kind of interwoven but separate, fault tolerance is this idea that I build into my solution redundancy, and so that it can roll with the punches. Right? The idea that it can handle small-scale failures, potentially with a degradation in service, but I can continue to operate. And the platform actually does a lot of this for you, which I'll go through. Disaster recovery is if I roll with too many punches and I get knocked out and a disaster happens, what's the processes and the policies and the technology that you put in place to recover from that disaster? Right? And then availability is obviously a measure of availability. Right? How available is your solution? And this isn't just across failures, but this is also across scheduled maintenance. Right? And so a highly available solution is essentially one that doesn't have downtime, regardless of whether it's scheduled maintenance, a small-scale failure, or a large-scale disaster. And so the first question you have to ask yourself when you're looking at what strategy I'm going to employ and how much I want to invest in these strategies, what do you actually care about protecting against? Do you only care about the large-scale failures and protecting your data? Do you care about protecting your users from small-scale failures? Do you care about maintaining service quality at a consistent level? What do you care about? All right? And the next question you have to ask yourself is, once I know what I'm protecting against, how much am I prepared to lose if that event happens? Right? And so industry term I'll kind of pepper throughout the presentation, and we use a lot through our documentation, is this idea of recovery point objective. And so the idea is how far am I willing to allow my application and my data to regress in the case of a disaster? All right? So if I took my backup an hour ago and a disaster happens 45 minutes into the next hour, If my recovery point objective for my business is 2 hours, then that's fine, because I've only lost 45 minutes worth of data. But if my recovery point objective for my business is only 5 minutes, then I've got a serious problem, because my high availability, my fault tolerant, my disaster recovery plans do not match what the business says their RPO is. And then linked to this is this idea that, well, that's fine that I've got a backup from an hour ago, but how long is it actually going to take me to restore full availability of my system? And this is a term we call recovery time objective. All right? And so you'll actually see this in our documentation around things like geo-redundancy for blob storage. We don't put an SLA around this, which is an important point. We do not provide SLAs around RPO and RTO. We do give some indications though, right, about what you can expect, what data loss you can expect, and what recovery time you can expect. If your answer to both of these questions is approaching 0, you need a highly available geo-redundant solution, which, to spoilers, is going to be expensive. Right? And so you really have to consider what does the actual business need and weigh it up against some of these other considerations. Every single fault-tolerant disaster recovery or highly available feature you put into your solution is likely to negatively impact your performance. There's this other question about consistency. All right? So we're very familiar with the idea of local consistency within a single data center or within a local entity. But there's also an interesting thing when you go into the cloud about this idea of consistency across subsystems. So if I take the Azure world, how do I ensure consistency across SQL database, also known as SQL Azure, it used to be called SQL Azure, it's now called Windows Azure SQL Database. How do I ensure consistency across that versus blob storage, right? And then how do I manage geographic location? Actually, I was having a conversation just before this about this idea that if I want disaster recovery between, let's say, my on-premise site and Azure, how much is that actually reasonable given there's a large amount of distance between the data center and my local location, or between Azure data centers? All right? And so that will severely restrict some of your disaster recovery options and high availability options you actually have. Then obviously cost, right, is a big one. Weighed up against your SLA. What SLA are you providing to your customers? Right? And then the last one's an interesting one. It's this idea of compliance. And compliance is actually twofold when it comes to disaster recovery. One side of the coin says, if I've got very stringent compliance requirements that say my data must not leave the country or must not leave the state, for example, if you're reading the Health Privacy Ombudsman's report that says data must not leave the state, how do you do geographic redundancy, reasonable geographic redundancy, when I cannot move the data out of the state? The flip side of that is we're actually getting a lot of take-up in hybrid cloud scenarios where organisations need to meet certain compliance requirements around needing to have disaster recovery in place. Right? And so the cloud actually provides you with an interesting, very low-cost way to get disaster recovery to meet compliance requirements. So it's kind of a balance of all these things. And generally when we talk about high availability and disaster recovery, we frame it along this paradigm. All right? And I'm going to sort of talk around these different steps. The first one is this idea of cold DR, cold disaster recovery with local fault tolerance. And this is what you see mostly in Azure nowadays, and this is what you see for most systems nowadays, especially cloud-based systems, right? Because it's cheap, but recovery time's going to be a few hours. The next step above that, if you want to reduce your recovery time, is this concept of warm DR we'll look at. Above that is this idea of if I want next to no downtime, I need hot DR. If I want zero downtime, I need high availability, right? And with each step comes a exponential and incremental cost. Yeah? So let's jump in, enough of this kind of contextual stuff. Let's actually jump in and have a look at what some of these GeoDR architectures look like. So if we start with cold DR, and actually before I go through cold DR, what I want to do is start with what you get out of the box with Azure for fault tolerance, right? local fault tolerance. And so what I've got here is what is a very basic but very standard basis of an Azure architecture. So I've got two instances of a cloud service. So let's say this is a website sitting in a web role, right? Talking to a SQL database and talking to Azure storage in some way. This is going to be the basis for every kind of scenario I go through, but I will actually cover all the other pieces of the Azure platform as well. But I'm going to use this because it's kind of the basis of what most solutions are built on in some form. And so if I look at what do I get out of the box with Azure for fault tolerance, right? Keeping in mind fault tolerance is about adding redundancy so my application can roll with the punches that come with localized basic failures. Yeah? So if I start from the top of the stack, Azure obviously gives you a load balancer. But under that, I get this idea of automatic error detection and recovery, right? And so the idea sitting behind my cloud services or sitting under my cloud services is this brain. This brain's called the Fabric Controller. And what the Fabric Controller does is it understands the health of my cloud services, right? And so it understands if I'm getting errors thrown from hardware faults, there's agents within the instances which will pick that up and report it to the Fabric Controller. If I'm getting issues thrown from the operating system, if I'm getting unhandled exceptions from my application. These sort of things are picked up by the Fabric Controller. The Fabric Controller will cycle my instance out of the load balance set and recover it for me, all right? So you get, if you had one instance, you get recoverability, but you do not get fault tolerance. Because to get fault tolerance, you need two instances, you need redundancy. Which is why in Azure, we do not give you an SLA unless you're running two instances of each role. Because you can't do fault tolerance without redundancy. Yeah? So that's why I've got two instances. And then linked to this is this idea of fault domain. So if you have a look, each of those excuse me, each of those instances is sitting in its own fault domain. And within Azure, you can think of a fault domain as a single point of failure. So in a lot of our data centers, a fault domain actually maps physically to a rack. So if you imagine when you deploy your solution to Azure, what Azure is going to do is actually distribute your workload across the data center. The idea being that if faults in one rack, which is a fault isolation unit, occur, we'll take that one out of commission, but you can still operate, albeit at a slightly reduced capacity, you can still operate and roll with that fault. You do not get to control how many fault domains you'll put in and where we actually distribute you. You can query it through the APIs. What you can control is a slightly linked concept called upgrade domains. So not only are my two instances in their own fault domains, I also put them in their own upgrade domains. And you get to control how many upgrade domains you have. The idea with upgrade domains is if you want to do an in-place upgrade of those cloud services, what I'm going to do is, or what the load balancer will do is take one out of rotation, upgrade it, put it back in rotation, take the next one out of rotation, put it back in rotation. So you can maintain availability across unscheduled issues through fault domains and through scheduled maintenance through upgrade domains. Make sense? If you take it down a level and we start to look at SQL database or Windows Azure SQL database, so a lot of you might be familiar with it as SQL Azure, same thing, different name, right? A lot of you will be aware that we maintain 3 physical copies across fault domains. So what you actually get is when you create a SQL database in Azure, you actually get 3 physical copies spread across the data center. And we use a quorum style approach. So when you have a transaction come into the primary node, we won't return that transaction until we've synchronously committed it to 2 of those nodes. The third node is done asynchronously for performance. But what that means is you've always got at least 2, you're guaranteed to at least have 2 synchronously, transactionally consistent copies of your database spread across fault domains in the data center. You don't do anything, we don't do anything. It's all done without human intervention, right? And so what's going to happen is if my primary fails, then I'll switch over to my secondary and I'll stand up a new secondary and start replicating. You won't, as in the Fabric Controller will. We also offer the same type of thing for Azure storage conceptually. So for everything you store in Azure storage, you get local redundancy. So you get 3 physical copies, right, of your storage accounts, of the things you store in those storage accounts. Now, an important point here is this is a durability feature, not an availability feature, right? So we do this so that we will never lose your data center. We will never lose your data except if the entire data center goes down, right? And so the idea with fault domains and with this replication is that we can handle all faults for you, right, that are isolated to a single data center. As soon as you go across data center, it's a different story. But again, the replication is a durability feature, right? So what that means is if you make a request into SQL Azure or the storage subsystem, and your primary nodes are going into meltdown as you're making that request, that's not an issue for you because we'll just swap you over, but it's an issue for that transaction. That transaction will fail, right? So you need to build fault tolerance into your application to deal with those transient faults, right? They're transient because they're not permanent because we'll switch you over and start again. And so there's Patterns and Practices has this thing called the transient error handling block, which essentially does that for you. It's basically a retry mechanism, right? The last thing we've got that you can see on this picture is this idea of georeplication with Azure storage. So for your blob and table storage, you have the option to also get us to create 3 physical copies in a paired data center. It's on by default, but you can turn it off. It does come with a cost, right? And an important thing about this is it's also not an availability feature, it is a durability feature. And so if our data center has let's say we had an issue in December 2012 where the storage subsystem went down across the world, right? Oh, sorry, that's not true. It actually went down in, I think, US West, US Central, one of those. All right? You do not get to choose that you can then fail over to the geographic redundant copy, right? Because that copy is there so that we don't lose your data. It's not there at the moment so that you can quickly switch over and keep the availability of your application. That is changing, and we are putting enhancements in so that you'll get to choose, for example, when you fail over to the redundant copy, we'll also make the redundant copy readable for you. And so you get to choose, do you want durability? Do you want to optimize durability or do you want to optimize availability? Microsoft will always optimize durability, right? Because worst case scenario is we lose your data, right? And so that is what we will optimize for, not losing your data, right? The reason you might lose data in this scenario, well, twofold, is one, because it doesn't do queue storage at the moment, which they're also implementing. It only does blob and table storage. But also there is a latency. This is not a synchronous replication, it's an asynchronous replication. So this could be a few minutes behind. And so if you go back to the RPO and the RTO concept, right, the RPO of this is going to be a few minutes, right? The recovery point objective for this, there's no SLA, but the recovery point objective for this is a few minutes. The recovery time objective is 24 hours. Right? And so the expected recovery time, if we have a disaster in that data center, of recovering this is 24 hours. Yeah? So let's get back and have a look at cold DR. So this idea of cold DR is pretty much as it sounds, right? You start from cold, you start afresh, you start with nothing. And so in the case of a disaster, all I really have in place is a copy or a backup of my data. And so in this case, the 2 types of data I care about are Azure Storage and SQL Azure. Oh, sorry, SQL Database. How many times am I going to do SQL Azure? Azure Storage, you can either rely on georeplication if you're happy with the RPO and the RTO that we suggest or we say is going to be there. All right? Or there's a bunch of custom tools that allow you to essentially put a replication in place, and we're actually building one in my team to do a synchronization style capability. There's also a bunch of third-party tools which will do backups for you around this. If you're looking for SQL database, we do not have the standard SQL Server backup, restore type capabilities or replication capabilities in SQL database. All right? This is a platform as a service offering. We manage it all for you, all right? And you lose some capabilities. So what we have instead is this concept of export. All right? So what export does is it creates this file called a backpack. So it's basically this thing here, all right? And a backpack file is basically a zip of all of your object schemas as well as a bulk copy of your user data. All right? I've also put there from database copy because our recommendation is, the export is not transactionally consistent. What that means is the export could actually take a little bit of time, and during that time you'll be running transactions. We do not play those transactions through to the export, right? Versus database copy, whereas database copy is transactionally consistent. So what database copy does is it's literally a T-SQL statement that says create new database as copy of this database. And it does exactly what it sounds like. It just creates a new database as a copy of the original database. That is transactionally consistent, right? So what you do is you take a DB copy and then you export from that DB copy so you get a transactionally consistent export. And then to add the kind of geographic redundancy into this, you obviously copy that to a secondary data center or you point it at a storage account in a secondary data center. Now, worst case scenario, this data center goes down. What am I left with? Not a solution, not a deployment. I'm left with a bunch of storage, right? Which has hopefully backups of my storage accounts and backups of my database. And so what I need to do is redeploy from scratch. Take my original deployment package and redeploy it into Azure. All right? I need to restore my database from the backpack I've got, and I need to redirect my DNS. That's a lot of work, takes many hours, but that's what cold DR is about. It's incredibly cheap, and this is why it's the entry point. There's very little to next to no work in this, right? If you're happy to accept the fact that Microsoft has you covered for a lot of the local fault tolerance, right? And if you're happy to accept that disasters are very rare, and in the case of a disaster, then I'm happy just to maintain my data and have a few hours of reinstallation time, this is the approach you go for, right? This is what most people go for. What I want to do is go through some very simple demos, if I can work out how to switch over. So I want to go through, hey, there you go. I want to go through SQL database export if you haven't seen it. I also want to show you this concept of storage geo-replication quickly. And so I've got my Azure management portal. For those guys who haven't seen it, this is how you manage Azure essentially. I've got websites, virtual machines, blah, blah, blah. If I go down to my SQL database here, you can see I've got 3 databases which are spread across 3 different SQL database servers, which for the purposes of this demo is completely irrelevant. And for those, there's a little bit of a misunderstanding that server is actually a physical term. It's not, it's a logical term in Azure as well. So when we talk about server, we talk about a logical management unit. It's not a physical server because you'll be spread across, your databases will be spread across whatever servers we deem appropriate. If you have a look, each of these is deployed in East Asia, which translates to Hong Kong, somewhere in Hong Kong. All right, I'm going to grab this collection manager database, and if I have a look at the dashboard, one thing you'll notice is that I have no automatic export defined at the moment. All right, so what I can do is I can do a manual export, and everything I'm doing here for you IT pros in the audience is you can script it. You don't have to do it like this, but it makes for a much better demo than running a script. And so all I do is I give it a name, .backpack, right? I choose a blob storage account, and I'm going to choose GreyMe Dev Store. If I zoom out, what's interesting is you'll notice GreyMe Dev Store is in Southeast Asia, and I get a little warning here, right, which I'm sure you can't read, but essentially it says, be warned that your database and your storage account are in completely different regions, so that's going to cost you money. And the money it's going to cost you essentially is the transfer fees to get out of the Hong Kong data center, we don't charge you ingress, but we do charge you egress, right? And it also says it's not going to perform as well as it could if you're exporting locally. So part of your DR strategy needs to say, well, I might want to take more frequent, say twice a day exports, but I might only be interested really in actually having a geo-redundancy RPO, which is maybe 2 days old or 3 days old, right? And so all I do then is I choose the container, which I've already got a DB backups container. And for those that don't know, a container, so basically I've got blob storage. Blob storage hierarchy is I have an account. Under an account, I have blob storage, table storage, queue storage. Under blob storage, I have containers. Containers you can think of as like folders, basically. And so I'm going to put it in this folder, give it my SQL Server login, and this is where the server concept comes in. It's not a physical server, but it's a logical security unit. If I can remember my password. Right? And that's it. So that's going to go off and kick. I should say that's going to go off and kick off the export. That's going to take a few minutes, so we'll come back and have a look at that in a sec. If I want to make this automated, there's a preview at the moment of export status. So if I go to configure, I can put automatic export. What's interesting here is that you can't do less than a day, right? So if you want to do automated export, you are going to be stuck with an RPO of a day. Makes sense? Which in a cold DR scenario might be fine, right? And so to set this up, I set up a time. The great thing about the automated export, which a lot of people will get bitten with after a few months if they try and do it manually or try and script it, is this idea of having a retention period. So this will actually manage how many of the exports you're storing in blob storage as well. I give it my SQL Server login name and my login password. Yep. The other thing I can do, obviously, is import from one of my exports. And the great thing about the export is you can actually export from SQL Azure and import it into an on-premise SQL Server and vice versa. Yeah? So as a migration strategy, one of the ways we do a lot of migrations from on-premise environments is you cannot take a kind of a legacy SQL Server database, expect it to export, and then expect it to import into SQL database because there's too many things that SQL database may not support that you're using on-premise. So what you generally do is you'll use the migration wizard, which will essentially do what the export does, but then it actually blows out everything and does an analysis for you, right? Tells you what you need to change, and then once you've done that, you export it, re-import it, and then you can continue on with on-premise development and cloud development using the same database. And so if that hasn't kicked off, hey, that's finished, awesome. Okay, so my export's finished. So what I'll do is switch across to storage. And I want to show you two things here quickly. I'll show you where the export is, but I just want to, if I create a new storage account, and you see here I've got 4 storage accounts. One's across South Central US, Southeast Asia, West US, and Southeast Asia. So they're all in all different data centers. If I create a new one, all right, quick create, you'll see I've got this option here, which is enabled by default. Right, enable geo-replication. If I unselect it, this always makes you laugh. It tells you if you unselect it that if you reselect it, it's going to cost you money, but it doesn't actually tell you it will cost you money by leaving it on default. So to give you an idea, if you're under a terabyte of data and you're doing pay-as-you-go, it tends to be, I think it's about 9 cents a gig for geo-redundant, and it's about 7.5 cents for local redundant. So there is a 2.5 cent difference in per gig in doing geo-redundancy, which doesn't sound like a lot, but if you've got hundreds and hundreds of terabytes or petabytes of data, it can add up. So you need to work out whether you want that. It's at an account level as well, you need to be aware, right? So you can't turn it on off containers. The other thing you can't do is you can't actually control what the secondary data center is. And so if I go and have a look at GTest, for example, which has geo-replication enabled, you can see my primary is South Central, my secondary is North Central. If I look at GreyMe Dev, right, my primary is Southeast Asia, my secondary is East Asia, this one is West US versus East US, right? So we pair the data centers, you don't get to pair the data centers, if that makes sense. Yeah? And then this last one, I'll just quickly show you how you turn it off because geo-replication is disabled. I go to configure and I click on and save. And that's it. Yep, and now I basically have added geo-redundancy to table and blob storage. I'll just quickly show you. This is where the export ended up. So if I go to GreyMe Dev Store, go to my containers, go to DB Backups, you can see, what's today's date? 12:01, so it would have been that one, right? So that's the backup I did today. Yep, that's the export I did today, sorry. So let's go back here. Cool, that worked. Okay, so quick demo of that. So let's talk very briefly about regions, subregions, and data centers in the context of that geo-replication. Here is our data centers, here is our regions, here is our planned data centers, right? So currently today, we had North American region, European region, and Asia Pacific region, which is turning into Asia Pacific area because we are adding 3 new regions to Asia Pacific. One of those regions is Australia, one of those regions is China, mainland China, and one of those regions is Japan, all right? And so what that means is we will pair data centers within a region. And so if you move to the Australian data center or data centers when they're available, we will pair East Australia with Southeast Asia. So there's no issue with your geo-redundancy will not be sent to Singapore, right? This is true in the US, it's not true in Europe. The 2 European data centers and the sub-regions are not in the same countries. One's in Dublin, one's in Amsterdam, right? Likewise for Southeast Asia and East Asia, they are not in the same country, right? One's in Hong Kong and one's in Singapore. So if you look at, what I wanted to do now is look at some other building blocks in Azure, because what I presented to you before was here's a very basic architecture with cloud services and a database and storage. But what I quickly wanted to do is go through and make sure I don't miss out on some of the other things you might be using. So instead of using cloud services, I could be using virtual machines, right? So virtual machines don't have the concept of fault domains, they have this concept of availability sets. Availability set is basically the same as a fault domain or maps to a fault domain. The main difference is when you think about it, if you give Azure a web role and you say, I want 2 instances of this web role, we know that they should be in separate fault domains. And we know that because they're exactly the same. If you create, in a virtual machine world, that's not what you do. You create one virtual machine with your website, and then you create a second virtual machine with your website, right? And we have no idea that they're the same until you tell us this is an availability set, yeah? And then when you tell us this is an availability set, we will go, great, we'll put them in separate fault domains for you. Make sense? It's also why you need to define for us the load balance set, because we don't know what the heck you want load balanced in virtual machines. Yep. Interesting, lovely feature of virtual machines is with cloud storage, and this is more when we get to warm DR, is you actually get, so for cloud services, you'll get charged if the instances are stopped. Yeah? Virtual machines, if they're stopped and deallocated, which means you've stopped them from the portal and not gone into the machine and shut it down, you will not get charged for that, which is extremely handy in warm DR scenarios. Yeah? One of the most common workloads we see in virtual machines today is running SQL Server. So I don't want SQL database for various reasons. I want to implement my own SQL Server, and so I put it in a virtual machine. And I'll talk about this more when we get to the hot DR scenarios, but the idea here is I can support most HA and DR in some form. Yeah? Then from a DR point of view, I basically have the same concept as I do with web and worker roles, is I need to recreate them from scratch. The only difference here is that I've got a number of different options. I can recreate them from a script. I can recreation from a snapshot of the image I created. So I can basically get the VHD, snapshot it, store that snapshot. Doesn't do much for the data. But then the last one is I can recreate it from the disks. So for those that aren't aware, how virtual machines work is virtual machines have two different types of disks sitting behind them. There's an OS disk, which has the operating system stuff you install, and then I attach data disks. So I can attach like 16 1 terabyte data disks to this, right? So what happens with these disks is they're actually page blobs sitting in blob storage. And so in theory, a DR strategy would be, I just let geographic redundancy copy those over to the secondary data center. In case of a DR, I go and get those disks and recreate and reattach my disk to a virtual machine I create. Yeah? It works in theory. In practice, there are some issues, especially around SQL Server workloads we'll talk about. So quickly hammering through these. So the other option I've got is I don't want to use compute services, I don't want to use virtual machines, I want to use websites. Yeah. And so for websites, I've got built-in tolerance for if you're using shared or standard mode versus the free tier. We've got built-in fault tolerance, and the cool thing about this is we actually have failure detection and fault tolerance with a single instance, which we don't have with cloud services, and that sounds really weird, but what it is we have a pool of servers which are associated to your workload, and if we're going to run scheduled maintenance, we'll actually move your workload to one that isn't scheduled maintenance, or isn't going to be maintained. So you get automatic load balancing at scale, but from a DR point of view, it's exactly the same as cloud services. You need to redeploy it. Caching's an interesting one, and most people don't think about caching when they think about when they talk about HA or DR, until your application, which is getting hammered and relies on cache, and the cache goes down, and then all of a sudden, all of those requests are going back to the database, right? Because they're getting cache misses, and then your application fails because your database gets throttled. Yeah? I see this a lot when people don't put HA onto their caching. So caching has two modes. There's caching when you actually cache it, you actually use your existing roles within a web or worker role as the cache host. And in the role configuration, you can configure them for HA. The shared caching, which if you haven't seen it, we announced yesterday a new version of shared caching, which is much, much better because it doesn't have throttling on, and it's much more performant than the old shared caching. But that doesn't have HA support. Although because it sits on Azure infrastructure, it is fault tolerant. But the difference is with HA around caching, what caching HA will do is actually create replicas of all of your objects across fault domains. It is across fault domains though, and not across data centers. If you want to do it across data centers, you need to redeploy this when you redeploy in a disaster. The last three are interesting, but aren't that concerning because frankly, they're not meant to store durable state, right? Which is why I can take a tear down and rebuild approach because there should be no durable state in those. I store my durable state in databases or in the service bus. The service bus holds durable state, right? So if you don't know what service bus is, it's basically our messaging framework or our messaging solution within Azure, one of the messaging solutions. So for Service Bus, you cannot use service namespaces that span data centers. So when you create a service namespace, it's for a single data center. We also don't have any automatic geo-replication of the data, which means it comes back to you to do it, all right? And there's kind of three considerations that you need to do, whether you're doing relayed messaging, brokered messaging, and then there's the client. And we have samples for each of these. Basically, if you're doing relay messaging, there's this idea of geo-replication. The idea is you stand up two service namespaces and the client will essentially pick one, and whichever one it picks is the primary, and it will start posting to the primary. If that goes down, it chooses the secondary, and the server basically checks both queues. All right? For brokered messaging, we have an active and a passive mode. Active is basically you post to both queues. Passive is you basically choose one and use the same kind of approach as you do with relayed messaging. The reverse of that is on the client. If I can handle, my application might actually be able to handle the fact the service bus is down, but I must not lose the message because that represents durable state in my application. And so we have this sample, which is a durable client-side queue. The idea is if my queue's not available when I'm trying to post to it, the sample uses MSMQ locally to post to a local queue. Yeah? You can also obviously use a database or whatever. The idea is not to lose that state. Identity, we have, so identity being access control service and Windows Azure Active Directory. So we have HA and resilience within a single data center. From a DR point of view, if you're using ACS 1.0 namespaces, there is no recovery of your data, and it's deprecated anyway, so you shouldn't be using it. ACS 2, we take offsite backups daily, right? So your RPO is going to be 24 hours. If you want a smaller RPO than that, we also have a bunch of PowerShell scripts which allow you to create your own backups for this. For mobile media and SQL reporting, they're all basically the same. We have HA and resilience within a single data center, right? DR is going to be a deploy, but a redeploy, but your DR scenario should really focus on the underlying data stores. So for mobile services are normally attached to a SQL database, so you use the process we spoke about before. If you're doing media, excuse me, the bulk of your storage is going to be blob storage. If you're doing SQL reporting, the bulk of your data is going to be SQL database data, and then you need to basically back up and redeploy your RDLs. Yeah? So what you'll see across all of these is kind of a common theme, right? We provide HA and fault tolerance within a data center, and then you need to consider how you're going to do DR, and mostly that will focus on the underlying storage mechanisms. So let's talk about warm DR. And so the idea with warm DR is instead of starting from absolute scratch, what I do is I have a semi-primed environment that I'm going into, all right? And so in this case, what I have is, if I put up, in this case, what I've done is I've stood up a cloud service, which only has one instance. I've turned it off, which is kind of stupid, to be honest, because I'm paying for it anyway, unless it's a virtual machine, so I may as well have it on, right? And what I'm doing is I'm keeping in sync storage and I'm priming the database, all right? The other thing you'll notice here is I've added this thing called Traffic Manager. So Windows Azure Traffic Manager, you can think of as essentially a global DNS load balancer, all right? So the idea is instead of hitting if I go back to this one, instead of hitting my cloud.net, cloudapp.net endpoint directly, I hit a Traffic Manager endpoint. And Traffic Manager has 3 modes it can run in. One is performance, which says send me to the nearest data center, right? One is round robin, which basically says send to this data center, then send to this one, then send to this one, send to this one, similar to how our internal load balancers work. And then the third option, which is what we care about, is failover. So we monitor the health of the endpoint, and if, based on various rules you define and we define internally, if we believe that's unhealthy, we basically redirect your traffic to the second data center. The idea being that you're not having to wait for global DNS propagation to flow through if you actually have to manually change these DNS settings. So from a storage point of view, my Azure storage is going to basically be the same. From SQL database, I can either do the backpack from DB copy with a continuous restore to keep my database primed, or there's also this thing called SQL Data Sync, and we don't actually generally recommend SQL Data Sync for use in backup. The main reason is it's actually still in preview, so we don't want you to use it for mission-critical production systems. It also does have a few limitations around schema, what schema it supports. It doesn't do versioning, and it doesn't do objects within the database. It just does the database tables or the data, right? But it has some very large advantages. So export, as you can imagine, takes the entire database and drops it into a file. What SQL Data Sync does is it basically trickle feeds the changes through as they come through using triggers and change data capture style tables. Yeah? So it's actually very useful in scenarios where at worst case scenario, if you want to stand up your application, there might only be a few tables which are deemed mission critical. All right? And so we've got a lot of scenarios where ISVs will use data sync to actually just data sync or synchronize a few of those tables and then use export as the basis for the other tables. What you'll notice here is there's not a lot of difference here between cold and warm DR. And so what we actually find is a lot of people who need a solid warm DR strategy will actually start to merge in some hot DR capabilities, which we'll talk about. And so what you often find is you actually often find the compute tier is a warm DR scenario on standby, but the database tier, which I want to keep primed, I actually leave as a hot DR scenario. Make sense? And so if my primary data center goes down, traffic manager is going to switch over the traffic to the secondary data center. And then what I need to do is have some sort of scaling mechanism so I can bring my warm instances back up to the level of capability that my original data center had. So what I might do is give you a quick demo if you haven't seen Traffic Manager in action and SQL Data Sync. Cool. And so what I've got is, so if I look at my cloud services, I've got this TechEd1 and TechEd2 website. One's in, excuse me, one's in Southeast Asia, one's in North Central US. Right? So if I look at my TechEd1 application and my TechEd2 application, realistically, these are going to be the same. I've made them different because it looks cool in a demo. But obviously, you're going to have those at the same. And what I actually want to do is I actually want to do failover across those. So what I'm going to do is come down to Traffic Manager, create a new Traffic Manager profile. Let's give it a name. TechEd will do. And my method's going to be failover. I select my endpoints, which is going to be that guy and that guy. All right, that's going to take a few minutes. Let's get rid of those guys. That's going to take a few minutes to create. And once it's created, I've got my endpoints, which it will take a little bit of time to understand the status of those endpoints. All right. In the meantime, what I'll do is I'll configure the monitoring on it to reduce the DNS time to live so that it fails over quicker. All right. I've got my failover point, and then all I've got is this simple monitoring stat. So the idea here is what I'm doing is I'm actually just hitting the main HTTP address to say check essentially if you get a valid HTTP code back. And it'll do 4 retries over essentially an exponential time frame to check whether it's alive before it flags it as unhealthy. More realistically, what I would actually do is set up an endpoint specifically for this monitoring that actually goes through and exercises my application. Yeah? Because this doesn't tell me whether my database is healthy, it doesn't tell me whether my storage is healthy. So what I actually want to do is create a canary transaction that this will hit, but for the moment I'm just going to leave it like this. Excuse me. And so if this guy is up and running, excuse me. All right, so that's online. So if I hit this guy now, we should see both endpoints it thinks are healthy, right? So we've got TechEd2 online. I've forgotten what I called it. So let's go back here and copy that. Yes. All right, so go to my TechEd Traffic Manager. You'll see I hit the first endpoint. And if I keep hitting that, I'm still going to hit the first endpoint. All right? So what I'm going to do is make the first endpoint die a slow, painful death. All right? So stop this guy. Whoopsie. Stop. Okay, and that's going to go through counselling and take a while to stop. So while that stops, what I'll do is I'll quickly show you SQL Data Sync. While we're waiting for that guy to stop itself and then Traffic Manager to pick up its health. So for data sync, I simply go into SQL Database, and you can, again, script all this. And let's take Collection Manager. And I've got this idea of, excuse me. Oops, go to Collection Manager. I can add sync, and so I can create a new sync group which is basically the scheduling controlling mechanism for this, or I can add a new sync agent. And that's used for when I want to do secure sync between an on-premise data center or an on-premise SQL server and a SQL Azure or a SQL database in Azure. So let's add a new sync group. I'll give it a name, TechEd sync. Oops, I can spell. Let's put it in East Asia, sounds good. I choose my hub, which is basically going to be my source database. In this case, let's do collection manager. Give the server a name. Give it a password. Right? And then I can do one-way sync this way, one-way sync this way, or I can do dual sync, right? If I've been a little bit silly and created a multi-master environment. And we support, SQL Data Sync only supports conflict resolution to the level of do you win or you win? Yeah? If you need much more detailed or complex conflict resolution, you essentially need to build your own sync framework. This is actually built on top of the .NET Sync framework. And essentially what it is you can think of it as a scheduling and security engine on top of the .NET Sync framework. So I'm just going to say the hub always wins. I'm going to choose what my reference database is, which used to be called member database. Do the same sort of stuff. Right, and I'm going to say I actually want to sync from the hub, because all I'm doing in this scenario is I'm basically just drawing down from the hub so I can create a local copy. Yeah. And so then if I've got my sync, I can go in and do a bunch of config, which I won't do because it takes a little bit of time, but you can see I can set up auto sync. And interesting here is I can do up to 5 minutes, right? Or I can do as little as 5 minutes synchronization, right? And then what I can do set up my sync rules, and my sync rules are going to say what tables am I synchronizing, right? And essentially go through, and there's a bunch of logs and that sort of stuff, you can track it. So what I quickly want to do is, hopefully this guy by now has recognized that my traffic manager, you can see that my endpoint's gone offline, yep, because I've stopped that endpoint. And so if I go back here, and I think that's still in my paste buffer, isn't it? If I go back and hit my traffic manager endpoint, TechEd traffic manager, I'm going to hit my second website because I've failed over. Traffic manager has failed me over to wherever this is, US, I think, or I can't remember which one was which. Make sense? So that is traffic manager and SQL Data Sync. Cool. So let's talk about hot DR. And there's two scenarios I've presented here that I see for hot DR that we've implemented before. One is using SQL database, and the second one that I've introduced is using SQL Server within a VM role. The reason I've introduced SQL Server in a VM role is because, to be honest, if you need to do hot DR and high availability, then most people will look towards doing SQL Server in a VM role because you need to get access to the type of DR capabilities that come with an on-premise SQL Server environment. But let's talk about what a hot DR scenario with SQL database would look like. So the big thing about hot DR, obviously, is I have 2 DR sites. So if I look at my last traffic manager demo, I had 2 hot sites. Both were running, so traffic manager could just switch me over, and my users wouldn't have noticed the difference, right? Well, if the sites had been the same and one wasn't green and one was blue, but you know what I mean, right? And so I've got my dual instances here, and then it always comes back to what am I going to do with storage? Now, for Azure blob storage and table storage, it's no longer sufficient for me to rely on this idea of, excuse me, it's no longer sufficient for me to rely on geo-replication because hot DR does not equal a 24-hour turnaround time, right, or an RTO. And so then I either need to introduce a custom replication model if I'm happy to go with a eventually consistent model, which we'll talk about more with the database, versus an ACID-style consistency model. The other option is there's this concept of a high availability proxy. And the Active Directory team actually released an example high availability proxy for REST services on GitHub about 2 months ago. You can have a look at how this is done. Basically uses a quorum-style approach similar to what we do with local SQL database to essentially create a header service, excuse me, creates a header service that I hit, and that header service will basically run the transaction against 2 different REST services. So in this case, I'm going to send the transaction to my local storage, and then I'm going to send it to my geo-redundant storage. That's going to have a big performance impact if you're a heavy user of storage, right? Yeah. Which is why if you move to the SQL database route, you could do a HA proxy style approach, but it's unlikely that will ever work for you because the latency is just going to be too great and you're going to kill your solution. And so what we go with more around this when we talk about SQL database is this thing we call eventual consistency, right? And so the idea being that at a split second in the day, my hot data center is not going to be exactly consistent with my primary data center because the transactions could still be sitting on service bus. So how this works is when I post a transaction to the database, I also post it to the service bus. And then my secondary data center is going to pick that up, right, and eventually apply that transaction. And then what's going to happen is, obviously, my first data center goes down, traffic manager switches me over, and I can immediately start handling the load. One of the problems with this scenario is you need to build in the capability that then you need to reverse that entire process, right, which is a very custom style approach. So the more common approach we see is this idea if you want to do HA or hot HA at the database level, even if you're doing warm HA or warm DR at the compute level, is you actually use SQL Server in a VM. And so the idea here is my storage is going to be the same, but for SQL Server in a VM, I get to do database mirroring or I get to do URL or backup to a URL and continuous restore. I don't today get to do availability groups, right? I will do soon, but today I don't get to do that, and I'll explain why in a sec. So what I want to quickly finish on in the last kind of 5 minutes is what are these SQL Server and Azure HA and DR scenarios, and what does it look like? What technologies can you use, and how do you do it? And there's really 3 scenarios we see. The first is doing HA within Azure, so doing it within a single data center. And what you're actually doing here is you're trying to get back to the point that you already would have had if you use SQL database, right? Because SQL database already has this in place. But if you choose to use SQL Server in a VM role, within virtual machines, which is completely valid and good thing to do in certain scenarios, then you need to apply your own HA. The next one is our GeoDR scenario, which is doing DR across Azure data centers. And then the last one, which I'm not going to cover now, I'm going to cover in my hybrid session this evening, or this afternoon, is doing DR between on-premise and doing an Azure and doing vice versa. And so if I talk about doing SQL Server HA within Azure, the obvious question is, well, why would I do this? Because Microsoft already has automatic error detection and recoverability for my VM. And yes, that is true, and we spoke about that when we spoke about local fault tolerance. But that failure detection is only for the VM and the operating system. We know nothing about what you run in that workload. Yeah? And so we will manage things like hardware failure. We will manage the fact that Windows is throwing a whole bunch of exceptions. What we don't understand is if SQL Server, one of the processes is hung, SQL Server's unhappy and is in meltdown mode, one of your disks has detached, one of your log files is corrupt, whatever it is, no idea, right? And so that's just going to sit there and churn because we don't understand what you run in that virtual machine. The next one is even if you do rely on the service healing with a single instance will take 12 minutes minimum, right? And so if you're talking about a hot DR scenario or even a fault-tolerant scenario, 12 minutes is not a fault-tolerant solution, right? And then worse is if we do Azure upgrades, and we saw this a lot when we had the preview of infrastructure as a service, and we had a lot of ISVs kind of jump onto that preview, stand up these awesome SQL Server environments with a single node, and then complain when we rolled through the data center and made upgrades, right? What happens when we make upgrades? We basically bounce the machines, right? Upgrade the OS and restore the machine. That's 15 minutes of downtime, right? So that's why you need this, right? And this is essentially, I stand up 2 VMs, I put them in an availability set, right? And then I use availability groups in SQL, right? By the way, availability groups and availability set have nothing to do with each other, right? One's a Windows Azure concept, one's a SQL concept. So what I do is have an availability group where I've got my primary here. It basically, if that falls down, the secondary picks up the primary, et cetera, right? And that takes about 15 to 20 seconds, which is much better than 12 to 15 minutes. Yeah? And so what technologies are supported or recommended? There's obviously, you can do log shipping and a bunch of other stuff. But these are the 2 we recommend. Availability groups and database mirroring. So availability groups, if you're not aware, it's a new thing in SQL Server 2012. We don't support clustering, by the way. The great thing about availability groups is you get 0 data loss in synchronous mode, right? And the scope is at a database level. So if this thing falls over, you basically have one availability group scope, which the whole thing fails over with all your databases, versus database mirroring, where you need a separate database mirroring session for each database. The more interesting scenario is the last one about these readable secondaries. So availability groups, gives you readable secondaries, which is really cool because you can do things like put your backups on the secondary. Right? So instead of doing your backups on the primary, you do it on the secondary, or you can run reporting off the secondary. You can't really do that with database mirroring unless you kind of work around it with database snapshots, which we don't necessarily look at. But so the recommendation is to do availability groups. So an important point here is that the technology that underlies this and the concepts are exactly the same as what you do on premise. How you do it is very, very different because of how you set up the networks in Azure. And so if you want to do this, you can take your knowledge from on-premise, but do not take the process from on-premise. You need to take the guidance that we provide for Azure. And there's a 60-page document, there's a lab, there's a walkthrough, there's scripts, there's everything, right, to tell you how to do it, but make sure you follow that and not the on-premise version. Yep. And if you are running SQL Server in a VM, even if it's just a single one in a single data center, you pretty much have to do this if you want any sort of fault tolerance in your app. Yeah? So the other scenario, which is where we get into the geo idea of the world, is how do I do this across data centers? Right? And the question I get a lot is, well, but you do that for me. In theory, because if you remember our discussion about virtual machines, a virtual machine is backed by an OS disk and a bunch of data disks. They are actually backed by page blobs. Page blobs, if I enable geo-replication, will essentially go to my second data center anyway. This is true. All right? There's a number of problems with that concept. One is this idea that most SQL Server implementations are going to use multiple data disks. Mostly for performance, but also for size. So you basically stripe across multiple data disks. Yeah. The geo-redundancy in blob storage does not keep consistent the order of how we replicate the data disk or data across different disks, which breaks SQL Server recoverability. All right? Because it requires disk to be in exactly the right order so the logs are ahead of the data, for example. All right? And so if you've got multiple disks, you will break it if you try and recover from a geo-recovered replica that we've done for you. All right? That's one reason. The other reason is geo-replication, we've already said, has a potential RPO of a few minutes because it's an asynchronous replica. And it has an RTO of 24 hours. Even if you're doing warm DR, that's probably not going to be acceptable for you, right? And the last one is, hopefully, if you're putting a DR strategy in place, you test the DR strategy. You can't test Azure Storage Global DR, right? Because you can't control it. Because again, it's a durability feature, not a availability feature. So what do we support? We do not support availability groups. At the moment, we are going to support availability groups. The reason we don't support them is because availability groups require the two servers to be in the same Active Directory domain, right, which require a VNet across a virtual LAN across the two data centers. Azure does actually support through its virtual network doing VLANs, and ironically, you can easily do this between on-premise and Azure, but you cannot do it at the moment between two Azure data centers. You can't create a VLAN that spans two data centers. Okay? So you're left with two options, database mirroring and backup to backup to URL as a stopgap until we introduce that, allowing you to create a VNet across our two data centers. Right? And so database mirroring, if you want to do it today, is the recommended approach. And by the way, on the previous one, you would use database mirroring instead of availability groups if you aren't using SQL 2012, or if your DBAs are more familiar with mirroring and use mirroring on-premise, and that's what they're familiar with, right? And so that's a valid technology to use. Now, you get zero data loss with mirroring if you're in high safety mode. This is a little bit of a misleading slide, because I can tell you now you're not going to run high safety mode with database mirroring across two Azure data centers. The latency is going to be too high for you. So you're actually going to run high performance mode, which is asynchronous and therefore has the potential for data loss. Yep. So it's an important thing to understand. The other option you've got is backup to URL, which isn't really a DR scenario. It's a DR scenario, it's not a high availability scenario. And so backup to URL is your standard backup restore, but we're introducing this thing called backup to URL, which will allow you to essentially point your backups instead of at a file share. You can point them directly at Azure Blob Storage, right? Which is kind of cool when we look at some of the hybrid scenarios. You'll be able to point your backups directly at Azure Blob Storage. And so that's pretty much it. So hopefully you got an idea of what you can do today, some of the underlying technologies and some of the things that are coming, especially around SQL Server HA. Just want to leave you with some thoughts. So essentially you're going to own the responsibility for this availability and recovery. And you need to obviously offset the cost and complexity of each of these with the risk you're willing to bear, which largely comes down to what RPO and RTO are you looking for? What are you trying to address? And those other considerations we spoke about. But the other thing you need to make sure if you're a developer, you need to build into your app, which very few do at the moment. And if you're an IT pro, make sure your developers are, is how do you actually operate in a degraded manner, right? So if blob storage goes offline, your application shouldn't crash completely, right? It should be able to manage itself. If your cache goes offline, what happens? Anyway, with those last thoughts, I'd like to thank you. And if you've got any questions, please come up and grab me afterwards. Thanks.